All right, we're here doing chapter 17, problem number 14. It reads, what is the net torque of the bar shown in figure P7.14 about the axis indicated by the dot? And I've got that picture drawn here. This is another net torque problem. So we'll start out by saying that the net torque is going to be equal to the sums of this two torques right here. And we have two forces here, both of them at an angle. So we need to make sure we use the proper force here. This 10 Newton force is going to have a component that goes this way. We'll call it just 10 sub x. And it's also going to have a component that goes this way. We'll call that 10 sub y. And then the 8 Newton force also has an 8 sub y and an 8 sub x. In both cases, we want to use the y components of these forces because they are perpendicular to their lever arms. So we want to make sure we use the proper force. These x components both are parallel to the lever arm, so they create no torque. So keeping that in mind, this is the first part of this equation is going to be the F10 R10, and it's going to be the sine of 30 degrees. And then the other part of it is going to be this 8 Newton force is going to be F sub 8 times its radius and then times the sine of 40. So if we take all that stuff and we plug it in and we put it to work for us, we should get 10 times 0.75 times the sine of 30 minus 8 times 0.25 times the sine of 40. And when we do that, we get that the net torque is going to be 2.46 Newton meters in the counterclockwise direction. So that was problem number 14 from chapter 7.